So today we're going to look at two other ways that you have found triangles are congruent. And these other two ways that we're going to work with today are side angle side and side side side. And the law of cosines allows us to find the missing parts of triangles when we know those two things. So when we know side angle side or side side side, we're going to use the law of cosines. And here is the law of cosines. Right? Now, I would write down the third one here is the one that I do, because it actually, if you look at it, it looks exactly like something else with some additional stuff to it. What is c squared equals a squared plus b squared is what? Okay, the Pythagorean theorem. Okay, so this is the law of cosines is actually the Pythagorean theorem with a little part on the end which helps us to make adjustments for whether the angle we're working with is greater than 90 degrees or less than 90 degrees. And they actually show you up here how they actually use the Pythagorean theorem to develop the law of cosines. Like I said, I would just write down the last one. C squared equals a squared plus b squared minus 2ab times the cosine of angle C. So with law of sines, we use sines. When we know specific parts, angle, angle, side, angle. When we know at least two sides, then usually we're going to use the law of cosines. So here we have a triangle, ABC, where they tell us that side A is 8, side B is 5, and the measure of angle C is 32.2 degrees. And they want us to solve this triangle and round to the nearest tenth. So when I label this triangle then, to make it the easiest for me, I'm going to put C here. So side C is across from there. And then, because I'm putting C there because that's the angle they give me, all right, to actually make it easiest for me. And then side A is the bigger side of the other two, right? So then let's see, which one, this one's probably bigger, so I'll call this little a. So that'll be angle A, angle B, and side B when I fill them out. So we know that this is 32.2 degrees. The side B is 5, and side A is 8. So we know side angle side. So we're going to use the law of cosines to start with. All right? And the law of cosines then is going to, what it does is that, first of all, it finds the missing side. All right? So if I know two sides and the included angle, I'll use law of cosines to find the third side. So we set it up, c squared equals a squared plus b squared minus 2ab cosine of c. And then we just plug in what we know. A is 8, B is 5, And I can just plug that right into my calculator just the way it is. All right. Do not, okay, I repeat, do not break this up into pieces when you type it in your calculator. Do it as one piece, because what happens is people do that. When they do that, they break it in the wrong spots. Okay? So always type it in as one thing. Okay, 21.3, is that right? Okay. All right. So then we take the square root of 21.3. So C is approximately what? 4.6. Okay. All right. So the third side over here is 4.6. All right. So now we now know all three sides and an angle. We need to find the other two angles. So there's actually two ways to do this. All right. One is using the law of sines. One is still using the law of cosines, but we're going to wait for that, and we're actually going to develop that with the next problem. So we're going to use the law of sines then to find the other two missing angles. Because now I have enough information, I could fill out the law of sines because I now have an angle and side across from that angle. So I could use the law of sines now because I have one ratio from the law of sines. So then I can find the other ones. Yes?
So because 32.2 is the same as the other side, could you just add both 32.2 minus 180 to get the top angle?
I don't know what this angle is.
But like it's the same, so
How can it be the same?
because it's shaped.
Because of the picture I drew? Okay, you got to remember, the picture is not the scale. Okay? All right, the picture, remember, since B is 5 and C is 4.6, then these two have to be different. Okay? All right, it's a good try, though. So, the sine of, well, listen. All right, write it all out. So we've got the sine of A over A, sine of B over B, and sine of C over C. Okay. So here's our law of sines. So we'll plug in what we know. We don't know angle A, but we know side A is 8. We don't know angle B, but side B is 5. And we know that angle C is 32.2, and side C is 4.6. So we're going to put the ratio we know with the other two to find those angles. Now, do I need to find both of them this way? No, we could do what Jaylene was just talking about. If we knew one of them, A or B, then we could use the fact that all three of them add up to 180 to find the third one. So we really only need to find one of them. All right, so which letter do you like better, A or B? A, okay? So sine of A over 8 equals the sine of 32.2 over 4.6. Now this is one that we didn't talk about yesterday, and I did with fourth hour that was talking about what if I need, how do I do it to find an angle? Okay. So we get 4, oops. So since I'm trying to find angle A, all I need to do here then is multiply by 8. I don't need to cross multiply. All right, because I want to get the sine of A by itself. So instead of cross multiplying, I'm just going to multiply everything by 8. Okay? So the sine of A equals 8 times the sine of 32.2 over 4.6. So I'm going to type this in my calculator and I get a number. Okay. And I need to find angle A. How do I find angle A then? Is it the number I get when I type this into my calculator? No, because that's just the ratio. So, I do what?
Side and then what you get is your answer. That's my guess.
Okay, that's your guess. Any other guesses? Okay. Well, how did we, when we were doing those last week, how did we find the angle when we knew this stuff here?
You did like the inverse.
Right, we did the inverse. Okay, so we have to do the inverse. So we'll go to our calculator. Eight times the sine of 32.2 divided by 4.6 gives us 0.9267, and then we'll do the inverse sine of that answer. And we get 67.9 degrees. So A is approximately 67.9 degrees. So we can do the same thing to find angle B, or we can just do 180 minus 32.2 and plus 67.9. All right, so 180 minus the quantity of the other two angles added together. And that's still going to be an approximate because we're using those decimals there. So what do we get? 79.9 degrees. Okay. So we found angle B, found angle A, and we found side C. So we found the missing parts of that triangle. Okay. So we actually used the law of cosines and the law of sines here. Now, did we have to? No, we didn't. We could have just used the law of cosines to find the missing angles also, and I'm going to show you how to do that. All right, so example B, they just give us three sides. And they want us to find then the missing angles. Well, to do that, first of all, we are actually going to rewrite the law of cosines. Because if we're trying to find an angle, that means that we want this part here to be by itself. Because we want to get the cosine of C equals some number, so then I can do the inverse cosine to find the angle. So what we're going to do is we're actually going to solve for cosine of C, right? Because I want to get that by itself, right? And so this is when we know side, 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 we're going to use the law of cosines in this different version to be able to find the missing angles. Okay? So, what do I do first to solve for cosine of C? No, we're not plugging anything in. With this is non-existent right now. We're just taking this law of cosines and we're going to solve it for cosine of C. So I get that by itself. So I give you a formula that you can use, so all I got to do is just plug those numbers in and it's much easier to do. What do we do first if I want to solve that?
You have to subtract a squared and then b squared and put it on the other side.
Yep, good. First thing, you need to get rid of a squared and b squared. So we get c squared minus a squared minus b squared equals negative 2ab cosine of C. All right. So we're still trying to get that by itself. Do what? No, okay. Right, we want to get rid of that, the rest of this, right? What's happening here then? Right, there's multiplication. So to get rid of multiplication, we have to divide. So we're going to divide by negative 2ab. So the cosine of C equals c squared minus a squared minus b squared over negative 2ab. Now, when you're doing problems with these, okay, with this, right, the nice thing is that you have the fraction bar in your calculator, most of us, okay? So if you don't have a fraction bar in your calculator, you want to do two things, right? One is I would always calculate these numbers separately, all right, before I do the inverse cosine. Okay, let's look at if it's, how about angle A? If I wanted to find angle A, well, here's the thing. So let's look at this for a second. As I look at cosine of C equals this fraction, the angle I'm looking for is here. The side across from it is here. And everything else is what? Okay. All right. Well, it's an alphabetical order, but it's the other two sides.
Yeah.
Okay? It's all the other A's and B's. So if I want to find angle A, what goes in the numerator?
B squared. Negative 2b. No. A squared minus b squared minus c squared.
Yep, good. A squared has got to be the one that's positive, and then I have to subtract the other two squared in the numerator. Okay. And then the denominator is negative 2 BC. Okay. The angle I'm looking for goes here, the side across from it goes here, and then the other spots goes the other two letters. In any order you want. It doesn't matter the order. All right, and same with B. All right. So we're going to use these to find the missing angles then. And so once we found that 4.6 in example 1, we actually could have done this to find angles A and B. So, Jasmine, what's your favorite letter, A, B, or C? B, all right? So we're going to find B first here. Now, the thing is, can I just plug all the numbers into the original looking law of cosines and do it? You most certainly can. All right? But we've made it so that we now have formula for finding the missing angles when I know side, side, side. So cosine of B equals 9 squared minus 8 squared minus 7 squared over negative 2 times 8 times 7. So cosine of B equals, and what I would really, I think would be the easiest for you to do is just find these two numbers, and then we can do the inverse cosine of the fraction instead of it being a decimal to where you might be rounding. Okay? So I'm going to take my calculator, do 9 squared minus 8 squared minus 7 squared, and then negative 2 times 8 times 7. Okay, so I get negative 32 over negative 112. Well, what's a negative over a negative? Positive. Okay. So negative 32 over negative 112. So to find angle B then, I'm just going to do the inverse cosine of that fraction. Well, I'm just going to do 32 over 112 because they're both negative. Okay. Now, if you ever want to go back and use law of sines to find the other angles at some point in time, if you prefer to use the law of sines instead of using the law of cosines, then always, okay, find the largest angle first this way, using law of cosines. If you don't, you'll have a mistake, right? That's why the SSA theorem doesn't work, okay? Inverse cosine 32 divided by 112. All right, so we get 73.4 degrees. Okay. All right, so now, what's your next favorite letter, Jasmine? A? All right, so now we'll find A. Cosine of A equals, all right, we know it's A squared minus B squared minus C squared over negative 2BC. So all I need to know is which one is side A, and that's 8. So 8 squared minus 9 squared minus 7 squared over negative 2 times 9 times 7. So if you have the fraction bar, here's the other way you can do it on your calculator too, all right, is I can go ahead and use my fraction bar. 8 squared minus 9 squared minus 7 squared in the numerator, and negative 2 times 9 times 7 in the denominator. So I get this fraction. Oh good, mine already gave it a fraction anyways. Then remember, I can use the last answer feature of my calculator. Second cosine of the answer, so second negative sign puts that last answer in there, and then we get 58.4 degrees. But make sure at least on your paper you are writing out at least this much. Okay? What did I say? 58.4. Okay. And then we can do, to find the angle C, we know all three angles add up to what? 180 degrees. So what's angle C then? 48.2? Okay. So we found all three angles then, B, A, and C. So when we know side angle side, We use the law of cosines to find the third side of the triangle. Then we know all three sides at that point in time in one angle, so we could use the law of sines to find the other two angles, or you could use the law of cosines still when I'm trying to find an angle to find those other two angles, right? And it's up to you. You can do it either way if you want to use whichever one you want to use. Okay? All right. All right, here's a little application problem. All right, so we're going to do an application problem, and then we're going to and then we have a formula for finding the area of a triangle when we know all three sides. Yesterday we learned how to find the area of a triangle when we know side, angle, side. All right. Today we're going to learn a formula for finding the area when we know all three sides. All right, but let's do this application one. Hiker travels at an average speed of 2.5 miles an hour. How long will it take him to travel from the cave to the waterfall? And round to the nearest tenth of an hour when we get there. Right? So like we did yesterday with the law of sines problems, we want to identify what do I know first of all. And so once I have the picture drawn, my numbers on there, what parts of the triangle do I know? Okay. All right. I know a side, I know an angle, and a side. So I know side, angle, side, which tells me I'm going to use the law of cosines. And just like we looked at just a minute ago with finding the angles, that these two, regardless of your lettering, these two letters here are always the same. Okay? The side I'm looking for goes on the left side. The angle I know goes at the end. So 4 squared plus 3 squared minus 2 times 4 times 3 times the cosine of my angle, 71.7. Right. So c squared equals what? 17.5 miles. So the distance from the cave to the waterfall is 4.2 miles. Okay. All right. Does that answer the question? No, because they want to know how long will it take him to travel from the cave to the waterfall. So what do I need to do with this number? Okay, so we need to do our time would be 4.2 miles divided by 2.5 miles per hour. So how long does it take him to go from the cave to the waterfall? That would be 1.7. Okay, 1.7 hours. So the time from the cave to the waterfall is approximately 1.7 hours. Good. All right. Okay, last thing then is finding the area of a triangle when I know all three sides. And they give us a formula here called Heron's formula, but you could, if I know all three sides, I could use the law of cosines, find one of the angles, and then use the other formula I know when I know side angle side to find the area. Or you can use this formula here. Now first they ask us to find, part of this formula is finding S, which is half of the perimeter. Okay. And then we take that number, we multiply it by that number minus each side separately, multiply them all together, take the square root. But the first thing we do is we find the perimeter, or find half of the perimeter. So garden has a triangular flower bed with sides measuring 2 yards, 6 yards, and 7 yards. What's the area of the flower bed to the nearest tenth of a square yard? So we find S, and then to find the area, plug it into the formula. And you can calculate each of those numbers first, or you could type the whole thing in your calculator as it is. Either way, to get the answer. So what do we get this time? 5.5. Okay. So the area of this triangle is 5.5 square yards. So YD yards squared. Square yards. Okay. All right, so there's the law of cosine stuff. All right. If we know a side angle side, we can find the third side of the triangle. If we know all three sides, then we can use the law of cosines also to find the missing angles. And then we can use Heron's formula to find the area of a triangle when we know all three sides.